Welcome back from lunch. It's good to see all of you here. Are you enjoying yourself so far today? Yes? Wasn't that some rain we got last night, huh? I felt like I was here during monsoon season, and now it's hot, so that makes me feel better. That makes me feel like I'm in India, hot and sweaty. We're going to Hyderabad tomorrow. I heard it'll be even hotter there, yeah? Yeah? So lots of hot coffee and spicy food to make sure you enjoy the heat as well. So we are going to be talking about NoSQL today. Now, my name is Scott Davis. I run a consultancy in Denver, Colorado called thirstyhead.com. And I've written extensively about Java-based web development. My first book for O'Reilly was JBoss at Work. And when we're doing J2EE development, you tend to focus on not if you're going to have a database, but which database you're going to have. I've done a lot of work with Oracle, done work with MySQL, done work with Postgres. I wrote a number of books that involve mapping, web mapping, Google Maps, and GIS for web developers, something that focused on open source mapping. And when we were talking about open source mapping, a significant portion of that book had to do with Postgres, a relational database, and PostGIS, a spatial add-on to that database, so we could not only store strings and numbers, but we could store points, lines, and polygons, geographic data, but it was a relational database nonetheless. Spent a lot of time working with Groovy and Grails. I wrote Groovy recipes and getting started with Grails. I've written article series for IBM on practically Groovy and mastering Grails. And if you were here yesterday, you had an opportunity to hear Jeff Brown talk about GORM, the Grails object relational mapper. What I'm trying to tell you is I've spent my entire professional career dipped in relational databases. It is the de facto standard when you're going out there. Let me turn around and ask you, how many of you are using a relational database in your application right now? Yeah, look around. Lots of hands go up, yes? Well, for the past 6 or 7 years, I've been focusing on HTML5. And it's not that HTML5 is incompatible with relational databases. As a matter of fact, there's a standard web SQL that means I have a tiny little relational database, a SQLite database, built into almost every major browser out there. But as I got into HTML5 and started doing more work, I started finding solutions that were better suited for CouchDB, or better suited for Cassandra, or in this article series I've been writing for IBM for the past 6 months or so, mastering mean. And of course, mean is an acronym for MongoDB, Express, Angular, and Node. It's funny, my editor at IBM came up to me midway through the article series and she said, hey, is there any chance that we could swap out MongoDB for CouchDB? And I said, go ahead and spell mean for me. All right, now spell it more slowly. More slowly, think about what it starts with, Mongo. But her point was valid. Her point was valid that CouchDB could be a reasonable replacement for Mongo. And Mongo could be swapped out for Cassandra or any of these other kinds of NoSQL databases. So what we're going to talk about today is not one particular solution, but we're going to talk about a variety of different solutions out there. And maybe, just maybe, one of these solutions will suit the application you're working on as well. Does that make sense? Yeah? Good. Well, let me get one thing out of the way right now. I am not here to tell you that you're doing it wrong. I'm not here to tell you that you need to go back to work on Monday and delete the database off your system. No, don't do that. You'll get fired, first of all. That'd make me feel bad, yeah? Because I don't want you to think for one moment that I'm up here telling you that there is one true ring to rule them all, or one true persistence solution to rule them all. You should be very skeptical, shouldn't you? If someone comes up and says, oh, have I got the perfect solution for you? I don't know where you work, and I don't know what you do, but I've got the perfect solution for you. That doesn't make any sense, does it? Because there isn't one true ring to rule them all. In fact, there are many rings out there. There are many technology solutions out there. So instead, what you should pay attention to is someone who comes up and says, tell me what you're trying to accomplish. Tell me what problems you're trying to solve. Tell me what markets you're trying to enter, what platforms you're trying to tackle, what software solutions you're trying to put in place. Because what we need to do is understand the problem before we can suggest a solution. Yeah? I often call this the Goldilocks problem. Because some solutions have a little bit that would fit well, but it's way too big and complex for what you're trying to get accomplished. Other times, the solution works very well on a small scale, but doesn't grow to where you want it to be. So in every situation I come into, we look at the facts first. We look at what we're trying to accomplish, and then come up with the Goldilocks solution. One that's not too complicated, not too simple, not too hard, not too soft, not too hot, not too cold, but just right. Yeah? Because that's what we want to accomplish here today. In the next 60 minutes or so, we want to talk about a number of different problems and how each of these persistent solutions could potentially be the right solution. Because that is one of the biggest problems we face in software today. If you start by saying we're a Java and Oracle shop, you've already lost the battle, haven't you? And there's nothing wrong with Java. And there's nothing wrong with Oracle. I'd say the same thing to you if you said, oh yeah, we're a .NET shop. Or we're a Ruby on Rails shop. Or we're a PHP shop. Because what is that doing? That's putting the tools before the solution. We want to focus on the solution, then choose the right tools to accomplish what we're trying to accomplish. But it doesn't happen. So many times I come into an organization and a manager says, oh, we have the perfect solution, right? And they want this solution to be appropriate in every situation. And oftentimes this solution is a very expensive piece of software that the manager has signed a multi-year contract for, right? So she has a different set of motivations. Her motivation is, how do I justify this $10,000, $100,000, or multi-million-dollar contract I just signed? But we know that this one true ring to rule them all, this one multi-million-dollar piece of software, in fact, is a silver bullet. And we know that silver bullets don't exist, right? And we also know that through the holy, unholy alchemy that goes on in management's mind, this silver bullet somehow turns into a golden hammer. You've heard this before, haven't you? A golden hammer? It was actually Abraham Maslow. He's the psychologist that came up with the Maslow's hierarchy of needs and a number of other things. But he talks about Maslow's hammer in his book as well, where he says if all you have is a hammer, everything looks like a nail. Yeah? And so if that's what Maslow's hammer is, what's a golden hammer? Well, a golden hammer means you aren't even looking for nails anymore. Yeah, it's the appropriate tool for anything you're trying to do. What are you trying to do over here? Change a light bulb? I got a hammer. Right? Yeah, well, that's one way to get it accomplished, but that's certainly not the right tool for the job. All right. So, I even got yelled at by one of my colleagues because I kept saying MongoDB, the database we're using is Mongo. MongoDB, the database we're using is Mongo. He says, Mongo's not a database. It's a persistent store. I said, yeah, but it's so easy to say database. But I'm going to do my best in this presentation to talk about persistence solutions, even though it doesn't roll off the tongue nearly as well as databases do. And let me clear up one other misconception. NoSQL isn't what happens when you let your relational database, your DBAs, it's not what happens when you let them drink on the job, okay? NoSQL does not come from drunken DBAs. I don't know, he keeps spreading that rumor, but it's not true at all, okay? Drunken DBAs did not come up with NoSQL. All right. Every diagram we see as developers starts with something that looks like this, doesn't it? This relational database. I didn't even need to tell you what it is. There's our persistence solution right there. And I've said many times up on stage this week that I literally cannot remember a time when relational databases weren't a part of software development. Relational databases came out in the late 60s, early 70s. They are well established, they're well understood, they're rock solid, bulletproof persistence solutions. But they're a persistence solution that's appropriate for one set of problems, but not another set of problems. And so this is one of these solutions out there that is appropriate in certain circumstances, but not other circumstances. So instead of that cylinder that you see on many diagrams, this is how I think of relational databases. Silos. Silos, protected silos of information. Now, why do I think that? Well, what programming language do you use to interact with a database? SQL. Yeah, of course, that's what we're looking at right here, yeah? So then, of course, you write your entire application in SQL, right? Yeah, there are a couple of DBAs that raised their hands, yeah? No, they said, yeah, we don't need an operating system, we got a database. We don't need a programming language, we got SQL, we don't need, yeah. So this is what I mean by databases being a silo of information. They are not what you're going to write your entire application in. They're a dedicated piece of software that you install separately. You have a dedicated set of drivers that you need to use that are purpose-built for that database. And you have a very own programming language that you use. This doesn't make relational databases bad, but it does make them silos in your application. And you're saying to yourself, well, Scott, I haven't written SQL a long time, right? How many of you are Java developers? Oh, yes, then you are very familiar with Hibernate, aren't you? Or JPA, yes. How many of you are Ruby on Rails developers? Anyone? Okay, then you're familiar with Active Record, aren't you? Or Active Resource. Every programming language, every major framework out there tends to have some kind of ORM solution, which is an object relational mapper. And that's so you don't have to write SQL all the time. You can deal with your database in your language of choice, Java or C# or Ruby or Groovy, yeah? But there's a cost that comes with this object relational mapping. This is a dear friend of mine, Ted Neward. If you have an opportunity to speak, you should. He's a force of nature. He and I go to the same barber as well. Can you tell? Yeah? Yeah. But he famously said years ago that ORM, object relational mapping, is the Vietnam of computer science. What does he mean by that? Well, I don't know how well you know your American history. I'm an ugly American. I assume everyone knows American history, right? But Vietnam was not one of the great wars in American history. We didn't win that war. And part of the reason why we didn't win that war is because we thought, Vietnam, it's such a small country, such a tiny country. We don't need to send our entire army over. We'll just send a few advisors over. And then that few advisors grew to a couple more advisors, grew to a couple more years, grew to troops on the ground, and eventually we were mired in this war that ended up being unwinnable. And that is the ORM solution in a nutshell right there, isn't it? Because you go in thinking, this will be easy, right? I've got a person object over here that has a first name and a last name, so I'll just create a person table over here that has a first name and last name column. Okay, I understand strings and integers and booleans over here, and thankfully, I've got varchars and numbers and boolean columns over here, and so, yeah, this wouldn't be that hard, would it? Oh, boy. Yes, that's when the trouble begins, doesn't it? Because all of these are great solutions. And I really mean that honestly. There's a lot of expertise that goes into trying to write an object relational mapper to truly make it feel seamless as you go from objects to relational databases and back and forth. And this is what the ORM authors feel like they're writing. This majestic bridge, that bridges the Grails framework with my MySQL database. And in their mind, this is what they've written. And in reality, this is what they've written, hasn't it? Yes. Just enough to get over that water. This rickety thing that works just for your application, but not the second one, or the third one, or the fourth one. And sometimes the bridge goes out altogether, doesn't it? And then you're in big trouble. And this is what Ted Neward was talking about once again when he was talking about the Vietnam of computer science. Because if you start simple with attributes and columns, then it's fine. But how do you deal with one-to-many relationships? Well, you start saying, I guess, if I've got a one-to-many relationship over here in my relational database, I guess I could have a class that has an array list of elements in it, or a set of elements. And okay, that works well. And then, how do you deal with many-to-many relationships? Well, then I guess I could have two array lists or sets in there and begin joining these things together. And, that works fine going from a database to a class. But what happens if you go in the other direction? Oh boy. What happens if you have class person and class employee who extends person, and class manager who extends employee, and class hourly employee that extends person? How can you deal with a deeply nested hierarchy in a relational database? Do relational databases have that concept? Can I have one table extend another table? No. So there are some solutions out there. One is to have a table per hierarchy, which means I would create a person table that would have all the columns from that person object, but then I would have nullable columns as well, right? I would have a series of nullable columns for my employee, and a different set of nullable columns for my manager, and a different set of nullable columns for my hourly employee. Does that feel kind of dirty? Yeah, it should. It's not a good match, is it? Yeah. Well, your other option is not a table per hierarchy, but a table per class. So you have a person table that has a one-to-one relationship with a manager table. And that person table is a one-to-one relationship with an employee table, and a one-to-one relationship with an hourly employee table. That's fine as well, but you can't ever do a simple query anymore, can you? You can't do a query with at least one join. And it is impossible for you to do a query that iterates over all managers and employees and hourly employees if they're spread out amongst multiple tables. This is the problem we're faced with. Relational databases are good for what relational databases are good for. And I mean that honestly. Relational databases are good if you have naturally row-based data, naturally column-based data, if it fits nicely into these one-to-many relationships. But then what happens if you try to take that model and apply it to a different model? We end up having to do a lot of work, a lot of extra work, and make a lot of compromises. So then the only obvious solution, right, is that we should never use another relational database again in our lives. What? No, that's not it at all. Relational databases are good for what relational databases are good for. One of the things relational databases exceed at are transactions. Being able to make sure that you're trying to do a number of things and roll back the transaction if any piece of it fails. That's a great use case for a relational database. But there are also awful use cases for relational databases. Let's look at something like email. Yeah? Now, I'm not saying you can't store emails in a relational database. Of course, people have been doing that for years. But think about what email looks like. All right, we got a subject line. That's all good. How long is that subject line? Well, I don't know, as long as they want, I guess. Is there an as long as they want column in a database? No, you've got to say this will be a string and it'll be exactly 67 characters long. All right. Well, emails always have recipients, the two. So that's fine. We'll have a 2 column in our database. Oh, wait, but we can have multiple recipients, can't we? All right, so now I have a message and a recipient table, and that's a one-to-many relationship. One message can have many recipients. How about blind copies? How about CCs? Okay, well, fine. Then I will have some CCs and some BCCs carrying around. That's great. And then the body of the email. Oh, boy. There's no way we're going to be able to fit that body into 67 characters. So maybe we decide to put it in a blob or a clob, right? And while that gives you the opportunity to have an expandable body, can you then query on the content of that body? Can you index that? Yeah, typically no. And what are you going to do with email attachments? Right? What are you going to do with Word documents and images and MP3 files and videos? What are you going to do with multi-megabyte binary attachments? Are you going to encode it and store it in a cloud field? Do you see what I'm saying? This isn't an intrinsic problem with email, and this isn't an intrinsic problem with relational databases. It's a poor solution for the problem we're trying to solve. So this is where relational databases being used as a golden hammer kind of fall down. If you are familiar with document databases, brilliant. Document databases are a perfect match for an email solution, much like relational databases are the perfect solution for a banking transaction-based application. Yeah? We've got to be open to a whole host of possible solutions and choose the correct one for the job, not the one that we have already paid for. Yeah? So this is why I like the definition of NoSQL. That's not SQL, but not only SQL. Because that really encapsulates what I'm trying to get across to you today, is that there are a bunch of different persistence solutions out there. Each one has its own strengths and weaknesses. Each one will be appropriate in certain circumstances and inappropriate in other circumstances. Here are 3 popular solutions out there. There are many, many more, but these are ones that you'll hear people talk about regularly. MongoDB, that of course is the M in the mean stack. It's arguably probably the most popular solution out there. And you know the background behind that? It was called MongoDB. It's short for humongous DB. So you can see what they were trying to solve. They were trying to solve the problem of very, very large data sets. They also wanted to be a very web-friendly solution. CouchDB. I like Couch. I really do. Couch is an acronym for a cluster of unreliable commodity hardware. Did you know that? CouchDB, a cluster of unreliable commodity hardware. What problems are they trying to solve? Yeah? Did you know that Google, when it puts in a rack of servers to deal with this, they've done the analysis on this. And if one server fails in that rack, it's not worth their time to have a human go and pull that individual server out. So what they do is they monitor the number of failures and they have in a rack of servers. And once about a third of those servers have failed in there, the human will go in and pull the entire rack, not just the failed servers, but the entire one, and deal with it that way. Google embodies the notion of a commodity of unreliable, a cluster of unreliable commodity hardware. Yeah? And this is where the analogy has come. Do you want to have pets or do you want to have cattle? Because a pet is something precious that you name, that you form a personal relationship with. Oh, hi, Pookie, how are you? You're so cute. Yeah, Gucci, Gucci, Goo, yeah? That should not be your relationship with servers. You should have servers 1 through 100, and 99, 64, 27, and 13 are down right now. That's fine. We'll make more, right? Your servers should be commodity and cattle, not precious named family pets. So we've got Mongo, we've got Couch, we've got Cassandra. I love the name Cassandra. How many of you are familiar with your Greek mythology? Do you remember Cassandra? Yeah? Cassandra was dating Apollo, a Greek god at the time. And it's all good when you're dating a god until you break up. And then it's not good. You never want to break up with a god, right? Because when times were good, when Cassandra was dating Apollo, he gave her a wonderful power. He gave her the power to see the future. And when they broke up, he didn't take that power away. He did something even worse. He cast a spell on everyone else in her village that wouldn't allow them to believe her when she correctly predicted the future. Isn't that mean? Never break up with a god if you're dating a god. They're mean out there, yeah? So who would have ever dreamt that these NoSQL databases would have been as popular as they are all the way back in the 1990s? Would you have believed me if I told you that NoSQL databases were going to be a big deal in 20 years? Yeah? How many of you have done Lotus Notes development? Yeah. Now, how many of you use Lotus Notes as an email client? It's an awful email client, isn't it? It's terrible. But it is a wonderful document database. And one of the things that Lotus Notes nailed way back in the 1990s was synchronization. So being able to take a document from the server and pull it down to your laptop and then disconnect and make changes to it and then plug back in and have those changes synchronized back and forth. They nailed that back in the 1990s. So it's interesting that much like Firefox is the open source version of Netscape Navigator, kind of a failed commercial product, it's interesting that CouchDB is a very popular open source solution that sprung like the phoenix out of the ashes of a failed commercial project. It was a commercial project that was ahead of its time because we still thought that all things could be solved by relational databases. IBM had a hard time selling the concept of Lotus Notes. And so what they finally settled on is, well, no one here seems to understand document databases. Do you understand email? Okay, good. Well, then this is an email client. And not a very good one at that. So NoSQL, not only SQL, is a very broad umbrella that encompasses persistent solutions that have a variety of different capabilities. Back in 1998, a gentleman named Carlo Strazio coined the term NoSQL because he would come up with a database that didn't use SQL. And so he's like, hey, look, NoSQL. He went on to say, you know, a better name for my database probably wouldn't have been NoSQL, but NoRel, because it wasn't a relational database. But NoRel doesn't quite roll off the tongue nearly as nicely as NoSQL, does it? Yeah. But Eric Evans of domain-driven design fame, he repopularized that phrase several years later, and it began to stick. And if you know anything about domain-driven design, it's that your domain objects should be the center of your focus. It should be the crown jewels in your application. How many of you feel that the database is the crown jewel of your application? Yeah, DBAs raising their hands again, aren't they? I tell you. They think the whole world revolves around them, don't they? I'm kidding, of course. I'm kidding, of course. But this idea of domain-driven design, having a persistent solution that works well for your domain, rather than trying to map your objects to relationships, is something that has caught a lot of popularity in recent times. And you'll see that there are a number of different NoSQL databases out there. There are columnar databases. There are document databases. There are key value stores. There's a lot of variety in there. And once again, not every persistent solution is going to be appropriate for the problem you're trying to solve. But they do offer a host of interesting capabilities. So if we were to go and read up a little bit on MongoDB just from Wikipedia, they say right off the bat here that this is a document-oriented database. We all know what a document is, and so we should be thinking to ourselves, well, if I'm trying to store email and things like that, this might be appropriate. They go on to say that Mongo isn't a relational database, but they favor JSON documents. And you start saying to yourself, okay, well, especially if I'm a web developer, wouldn't it be nice if I had a database that spoke JSON naturally? That I didn't have to take a JDBC result set and transform it into JSON and send it downstream. Or take those uploaded JSON documents and transform them into relational databases on the other end. If you start using a document database that speaks JSON natively, you're able to cut a huge swath of logic, that whole ORM layer, completely out of your application stack. Now, CouchDB is up here on Wikipedia as well. It's another database, but you can see they are a database that completely embraces the web. There's no such thing as a CouchDB driver. You know what your driver is? HTTP. It's REST. This is a database that is fully RESTful out of the box. When you stand up a CouchDB database, you do HTTP gets to select documents out of that database instead of a SQL select statement. You do HTTP posts to add new documents to the database, not SQL inserts. You do HTTP puts to do updates. You do HTTP deletes to delete documents out. This is a database that, again, deals in native JSON documents, but you get a RESTful API out of the box as well. Cassandra. Cassandra, they say right off the bat there, it's an open source distributed database. A dear friend of mine, Tim Berglund, who has spoken here in the past, he worked for GitHub for a while, and now he's working for DataStax, a company behind Cassandra. And I asked him, does one instance of Cassandra make any sense? And it made him pause and think. He's like, I don't think one instance of Cassandra does make sense. Cassandra is meant to have a huge data set out of the box distributed over a cluster of these kinds of things. Cassandra was developed by Facebook. And so it is a solution for Facebook scale data management. So do you see what I'm saying? All of these are nominally NoSQL databases, but each one has a very different use case. Redis is a very popular one. But what is it? It's an open source, networked key value store. As a matter of fact, that's what Redis is short for. Redis means remote dictionary server. So you can imagine that the queries you're going to make are, here's a key, give me the value. Right? it's not absurd to even consider using multiple persistence solutions in the same application. Much like when I was talking about Vertex yesterday, I'm getting ready to start on a project that has Scala developers and Java developers and Groovy developers and JavaScript developers. And so Vertex is an application server that allows you to write verticals or segments of your app in all of those languages and more, and have them all run concurrently in the same app server and communicate across an event bus. I've never used Vertex before, because I've never had a client that had that particular set of needs. They said, here are the languages we want to support, but we want to try to unify. And I said, I've got something we should look into. The same is true with these NoSQL solutions. I've written applications that uses Redis for its caching solutions and uses CouchDB for certain aspects of the data that needs to be published directly on the web, and relational databases for when we need that strong transactional support. It is perfectly valid, and dare I say it, appropriate, to have more than one tool in your tool belt. If you have problems at your house and you call a plumber, are you concerned if that plumber shows up with a single wrench and says, all right, where are we at? What do we got to do? No, the plumber is going to show up with a whole truck full of various and different tools. And he's going to find just the right wrench or just the right blowtorch or just the right hacksaw or just the right tool for the job. And we should think of ourselves that way as well. Not having one golden hammer, but a whole tool belt full of tools that we can use to solve the problems that we need. If your data is row and column oriented, if you do like this SQL language, if it works well for you, then absolutely by all means use it. But if you've got a more document-oriented data set that you're trying to store, if like in the mean stack, you're trying to standardize on a single language, one of the huge benefits of the mean stack is that you've got JavaScript on the client in Angular, JavaScript on the server in Node.js and Express, and JavaScript in your database, your persistent store, as well. So, I made this point earlier. And it is so important to come back and make it again, that we should be focusing on the right tools for our solutions, not looking for solutions that fit the tools that we already own. So then, let's talk just briefly about JavaScript. And I do mean briefly, because in the mean stack, that's the language that you're using all over the place. And so if we look at some of the characteristics of JavaScript, we might find those characteristics match a persistent solution better than others. I love this quote. Whether or not it actually happened, I love this quote. Abraham Lincoln was said to have gone to a rich woman's house, and she laid out her finest linens and her best china, and she brought him something, and he very politely took a sip and handed it back to her. And he said, "Dear madam, if this is coffee, would you please bring me some tea? If this is tea, would you please bring me some coffee?" Yeah? Whatever this is awful. I'd like something else if you would, please. Yeah? No. Both are valid, hot, liquidy, caffeine delivery devices, aren't they? Yes? They are appropriate. They are the same in certain solutions, but they are very different in others. And similarly, Java is no better than JavaScript than coffee is to tea. They have different characteristics that make them more appropriate or less appropriate in certain circumstances. Because languages have characteristics. You've heard me say many times here that Java is a strongly typed language. That means the variables you declare have to be of a specific data type. But it's also statically typed, which means that all of your data types are determined at compile time. Once you've compiled your application and jarred and warred and eared it up and deployed it, it is set in stone, isn't it? So if you are a set in stone kind of person, you are going to be naturally attracted to a set in stone kind of programming language. But we also have dynamic languages, languages that allow you to meta-program, dynamically add new methods at runtime, dynamically add new fields at runtime. JavaScript is a weakly typed language as opposed to a strongly typed, which means that everything you do is just like throwing a variable in a var, right? Something that completely lacks type. So when you have characteristics that you like about a programming language, you will also most likely want to choose a persistent solution that matches or complements those same paradigms. This is what I think of when I think of variables in Java. An egg carton. And not because Java is brittle and weak. I would never stand up and tell you that, would I? No. What I mean is that egg carton is the perfect variable to hold egg-shaped data. This is the perfect variable for eggs. Would you use an egg carton to transport coffee? Or pancakes? Or masala dosa? No. It's the wrong-shaped variable for that kind of thing. So as you're declaring variables in a strongly typed language, you should be seeing them as shapes. And what happens when you try to put something like the string Scott in a person-shaped variable? Burp, right? Class, cast, exception. And isn't it brilliant in a strongly typed language that a class cast exception is so deeply nested in that hierarchy? It's brilliant, isn't it? Yeah? What kind of exception is this? Well, it's a runtime exception. Well, which kind of runtime exception? Well, it's a throwable exception. Well, which one is that? Yeah, you get the idea. It's a very strongly typed kind of exception. What is this? A duck-billed platypus. Is this a reptile or a mammal? It's a mammal that lays eggs, right? So if we're in a strongly typed system and we have reptiles and we have mammals, and we say that reptiles implement the egg-layable interface, we're a bit of a problem when we come to a duck-billed platypus, aren't we? What other mammals do you know have a beak and webbed feet? What other mammals do you know that are poisonous? This is one thing that many people don't know. A duck-billed platypus is the only poisonous mammal on the planet. Duck-billed platypuses don't fit very well in our strongly typed class hierarchy system, do they? Yeah. So some people say that software development, you're just modeling the real world, but you should never have a more perfect model than the real world, right? Your perfect model will almost always fall down when you are trying to deal with the messy reality of the real world. This is one reason why I'm such a big fan of JavaScript. These aren't strongly typed variables. It's a big metal bucket that you can pour anything you want to into it, right? You want to throw a string in there? Sure. Number? No problem. Boolean? You betcha. JSON? Object? Of course. Function? No problem. Right? I'm not saying that JavaScript is better or worse than Java. I'm saying it's got different characteristics. One of the things about databases is that they're strongly typed, and not just a little bit strongly typed, right? And so this is why strongly typed languages like Java lend themselves so nicely to strongly typed persistent solutions. Weakly typed languages like JavaScript, what are we going to do? Have a database that's nothing but blobs? One blob column after the next so we can manage whatever data type might happen to be in a JavaScript variable? Yeah. No, that's not going to work either. Because this is not a bug, it's a feature. JavaScript uses this idea of truthiness, and this is where the dreaded double equals comes in, right? So we start at the very beginning, we say 1 equals 1, that's true. Great, I agree. And then you say 1 equals true, and that's true, and you say, okay. 0 is false. Yeah. An empty string is false. Okay. The string 0 is false. Now what's going on now, huh? But you say, all right, I think I get the pattern. Let me see what I can do here. So the string true equals true. No. Oh, rats, okay. So false equals the string false. No, that's not it either. Oh, I thought I understood this. Okay. So 0 equals the string 0. Yes. And 0 equals the empty string. Yes. So by the transitive properties invested in me, I can now hereby say that the string 0 equals an empty string. Rats! Yeah, no, this is the truthiness going on. And the reason why we call these Truthy equations is because JavaScript is doing something called type coercion. It is changing the data type on the right-hand side of the equal sign to as best match as could on the left-hand side. And that is how it's trying to do equality evaluation. I didn't say you had to like this, but this is the way JavaScript works. And perhaps what you would like to do is read the documentation, because this is all laid out in the ECMAScript spec, and I know it's too small for you to read right there, but I wanted to prove to you that that truthiness, that type coercion that goes on, will fit into a single PowerPoint slide. So it is learnable, it is discoverable, and yes, it is deterministic as well. Yeah? But perhaps a better solution would be to simply use a triple equals. If you use 3 equals instead of 2, it turns off type coercion, and then all of a sudden you've got something that appears a lot more deterministic. You get falses all the way down, but in this case, that might be the behavior I want. Yeah? There are subtle nuances to dealing with these different languages. And there are subtle nuances to persistent stores, whether they're document-based or key value-based or meant to be distributed or meant to be loaded in a tiny browser. And it's a matter of you making sure you find the appropriate solution for the job. So what does all this have to do with MongoDB? Well, we've talked about a variety of different databases, but in one particular case in the mean stack, when you're trying to use a language up and down the stack, the same language across all tiers, and you have a language that has its own specific characteristics, you might want to choose a persistent solution that is the best fit for the language you happen to be using at the time. And that's MongoDB. And one of the reasons why it's such a popular mix in this mean stack, this Mongo, Express, Angular, and Node, is that MongoDB does a great job of reducing or even completely eliminating language impedance mismatch, as well as modeling impedance mismatch. So if you're dealing with JavaScript and you're dealing with JSON, you've got something that looks like this. You've got a name field, Sue. That's a string. Great, I can store that. I've got age, 26. Wonderful, I can store that. Status is an A. That's probably an enum, an enumeration, but great, I can store that. But then what about groups? If you immediately thought one-to-many relationship, that's fine. Just means you've been dipped in relational databases too long. What happens if we just decided to persist it as it is right there? What if we had a solution that would allow us to persist it right there, that we wouldn't have to transform it, that we wouldn't have to change it, that we could just natively store this in its native state and natively extract it. And that is what a document database does for you. That's specifically what MongoDB does for you. But CouchDB would allow you to do that as well. Any of these document databases would allow you to have an embedded array list. And what's interesting is when you start looking at the query language, well, that's in JavaScript as well. Even if you've never seen MongoDB before, if you looked at that query, db.users.find, that's our select. Age is greater than 18. You'll see a lot of curly braces in there because the query language is in JSON, just like the data is in JSON. And it's a little bit odd to look at if you're not used to it. But again, it's reducing that impedance mismatch that you're querying in JSON as well as getting results in JSON. So yeah, this allows me to get everyone who is ages greater than 18 and sort it by age. That age : 1, oh yeah, there's that truthiness, right? We could also say age true if we wanted to. Yeah, and that would sort it by age. What if we want to insert something? Like I said, we've got not tables and rows anymore. We've got collections and documents. And if that's the document you're used to dealing with on the client side, you can turn around and just say dbusers.insert. And all of a sudden it's been inserted directly into your database. And if you're worried about sophistication, Mongo has every bit of the sophistication you need. If you're starting to do an aggregate query now, you can say, all right, give me all the orders that have a status of A, but go ahead and group them by customer ID and sum them up by the amount. We have every bit of the sophistication we need. And we're doing it in a language that's internally consistent. We even have MapReduce. And when people say, I still don't get MapReduce, I say, well, wait a second. SQL is MapReduce. When you say select first name, last name, city, state, zip code from customers, what is that? That's a map. A map is what you use to select the fields that you're interested in. Select first name, last name, city, state, zip from customers, where state equals Colorado. What is the where clause? A reduce. Yes. So these concepts are the same. The syntax is different. But we have all the richness, all the sophistication, everything we need to have a good solution. Now, this is how MongoDB reduces language impedance mismatch. We can also talk about reducing the modeling impedance mismatch. And at the end of the day, what this means is whatever you can think of on the client, you end up saving it. But you're not just saving it in a blob, you're saving it as a JSON object. And that JSON object is queryable. Your query language allows you to search for main level docs and subdocs inside of it and arrays inside of that. Remember when we had those grades in there? I can say, show me everyone who has a grade of 95. And it doesn't matter if it's in a field or in an array. The query language that MongoDB uses says it doesn't make a difference to us. You ask me for people whose score was 95. And that's what I'll give you, whether that score is an individual value or in an array. And what we've discovered, especially in this last project I was working on, where they moved from a Microsoft SQL database to a MongoDB database, one of the things they said was, wow, we've been agile in all other aspects of the development process, except when it came to our relational database. Did you hear about the DBA that went out to a bar one night, met a beautiful woman, and he said, can I buy you a drink? And she said, well, yeah, that would be nice. And he says, you're the woman I'm going to marry. And she says, oh, that's very nice. And we're going to have 2 kids. That's creepy. And one's going to be born in 7 years and one's going to be born in 8 years. But before that, we're going to get married on April 25th at exactly 6 p.m. And then we're going to go on a honeymoon, and it's going to be 2 weeks, and it's going to be in Jamaica. What? Does that sound like a DBA? DBAs have been getting a lot of grief from me at this session. I like DBAs, I like databases. But if you sit down and decide to name every table and name every column and name every width of every column down to the character, is that very agile? No, it's not. MongoDB has primary keys, but it doesn't require joins. Arguably, that's the more performant solution because you have a single request, a single query to get everything back rather than having to deal with joins. Yeah? Not better, not worse, just different. And the reason Eric Evans got so excited about NoSQL solutions is because it's very natural for me to say, I've got a person who has a phone number and you want to just embed that phone number with them. I've got a person who has an address and you just want to embed that address with them. And if they end up having a work address and a home address, that's fine. You just change that to an array of subdocuments. If they have a cell phone and a business phone and a home phone, you just change that to an array. It's not a big deal. It doesn't change. It doesn't require massive changes on your part. It just forces you to take a domain-driven approach rather than a relational database modeling approach. So then, some of this may sound like heresy to you, but it's okay to denormalize your data. It's okay for one-to-one relationships to go away. It's even allowing us to create new terminology. One of the phrases we use an awful lot is, this is a true one-to-many relationship, or is it a one-to-few relationship? If we're modeling a household, we can say, well, that's probably a one-to-few relationship. At most, that house will have 2, 3, 4, half a dozen people. Even if it's a dozen people, that's fine. We still consider that household to be a one-to-few. Would consider embedding all those household members within the household so we can get it back as a single query. What if we were modeling all of the citizens of Bengaluru? That's not a one-to-few, is it? That's a one-to-many. And you also start thinking to yourself, would I ever want to get the Bangalore record without having all of the citizens? Would I ever want to get an individual citizen outside of the context of the city they live in? So when you're taking a domain-driven design approach, you begin coming up with terminology like one-to-few, one-to-many to help you decide to determine how that data should be shaped when you go to persist it. Both are valid solutions in MongoDB. But some of the things are the same regardless of what you're doing. You're going to have indexes if you want it to be performant. MongoDB supports indexes just like Oracle does. MongoDB supports clustering and failover just like Oracle does. Sharding is available to you in Mongo just like in other your databases. So you begin seeing here that each one of these tools has strengths and weaknesses. Each one of these tools naturally lend themselves to a certain class of solutions where they might be wholly inappropriate in other solutions. But don't be afraid to look at an alternate if it is a better fit for your domain, for your language, for your solution. Because at the end of the day, there is not one true ring to rule them all. When in fact, what you want to do is find that Goldilocks solution, that is solution that's not too hot, not too cold, not too big, not too small, not too complex, not too simple, but in fact, the perfect solution for what you're trying to solve. And that, my friends, is relational databases and NoSQL. Did you enjoy yourself? I did as well. Thank you so much. Thank you.